Hello everyone, I am Anandavalli. Welcome back to Guidance Education channel. In this video, we are continuing class 11 chemistry, chapter 4 chemical bonding and molecular structure. In this video, we will discuss Louis Langmuir theory. We have already seen that bonding in all molecules could not be explained by Covalent-Lewis concept. As per Covalent-Lewis concept, atoms enter into chemical bonding in order to achieve octet structure in their valence shell, that is, noble gas structure in the valence shell. Covalent-Lewis concept could explain electrochemical bonding, that is, ionic bonding. According to Lewis, the 8 electrons in the valence shell are positioned stationary at the 8 corners of a cube. Langmuir modified this concept. Before we pass on into the details of this video, please watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Okay? As per Lewis stationary cubical concept, this is the cube and these are the 8 corners: 1, 2, 3, 4, 5, 6, 7 and 8. The electrons are stationed at these 8 corners and they are stationary. Langmuir abandoned Lewis' concept of stationary cubical arrangement of the octet. He came forward with his concept and introduced the term covalent bond. What is a covalent bond? It is a bond formed by sharing of electrons. How is the ionic bond formed? Electrons are transferred from one atom to another atom. Electrons are wholly transferred from one atom to another atom. So one atom loses electron and another atom gains electron. In the case of covalent bond, the electrons are not totally transferred. It is only shared. Two atoms participating in a bond will share their electrons. We will go into the details of that. In order to understand that, we will consider a simple molecule, chlorine molecule, and then proceed to draw Lewis electron dot diagram for chlorine molecule. Cl2 is the symbol of chlorine molecule. What does this 2 stand for? It means there are 2 atoms of chlorine in one molecule of chlorine. It is a diatomic molecule. Di means 2. Can you recall the atomic number of chlorine? It is 17. So the electronic configuration is 2, 8, 7. So it tells us that chlorine has 7 electrons in its outermost shell. It requires one more electron to complete the octet. That is, to get the number 8. This is the Lewis electron dot diagram for chlorine atom number 1. There are 7 electrons in the outermost shell. 2 plus 2, 4 plus 2, 6 plus 1, 7. This is the electron dot diagram for the second atom. It also has 7 electrons. When they combine, it gives rise to chlorine molecule, that is Cl2. How can we represent chlorine molecule? As per Lewis electron dot diagram, we will show the imaginary boundary of the outermost shell so that we can easily explain the overlapping of the outer valence shells. This is atom number 1 and this is atom number 2. You find that the valence shell of these 2 atoms are overlapping, one above the other. with 1 electron each of the 2 atoms inside the overlapped portion. You find 2 electrons there. I will mark the valence shell electrons of atom number 1. How many are there? 1, 2, 3, 4, 5, 6 and 7. Similarly, for the second atom, 1, 2, 3, 4, 5, 6 and 7. These 2 electrons in the overlapped portion belong to 2 different chlorine atoms. Those electrons are shared by both atoms. Now, each chlorine atom has 8 electrons in its outermost shell. Chlorine number 1 has 8 electrons. Chlorine number 2 also has 8 electrons. The octet is completed. After sharing one pair of electron, the atom on the left hand side as well as the atom on the right hand side has 8 electrons each. These 8 electrons is achieved by sharing one pair of electrons. So, by sharing one pair of electrons, in the case of chlorine molecule, both the participating atoms achieve octet structure. So, this shared pair is common. It belongs to the atom on the left hand side as well as the atom on the right hand side. Okay? Now, both the atoms have 8 electrons in its valence shell. It can also be represented like this. Chlorine, single bond, chlorine. The single bond represents the shared pair of electrons. In the case of chlorine molecule, there are 6 electrons in each chlorine atom which do not take part in bond formation. That is, each chlorine atom has 3 pairs of electrons which do not take part in bond formation. They are called lone pair of electrons. The chlorine molecule can also be represented as Cl single bond Cl. But if you are asked to draw the electron dot diagram for chlorine molecule, then you have to show the bond and then also show the lone pairs. Supposing you are asked to represent the electron dot diagram of bond formation, then you have to show the overlapping of the valence shells and show the shared pair of electrons within the shared region. Now let us take up one more example, the example of water molecule. In the case of chlorine molecule, both the participating atoms are the same. But in the case of water molecule, there are 2 hydrogen atoms and 1 oxygen atom. What is the molecular formula of water? H2O. It means there are 2 hydrogen atoms and 1 oxygen atom. After bonding or after forming the covalent bond, hydrogen will come to contain 2 electrons, which is the structure of the nearest noble gas, helium, which has only 2 electrons, and oxygen will come to have 8 electrons. That is the octet structure, which is the structure of the nearest noble gas, neon, which has 8 electrons in its outermost shell. For hydrogen, atomic number is 1. That means it has only 1 electron and it requires 1 more electron. There is 1 more hydrogen atom. It also requires 1 electron. What about oxygen? Atomic number of oxygen is 8. Electron configuration is 2, 6. That means it has 6 electrons in its outermost shell. It requires 2 more electrons to complete the octet. 2 electrons of oxygen in the outermost shell shares 1 electron each with the electron of each hydrogen atom. So, oxygen gets 8 electrons and hydrogen gets duplet structure of helium atom. Let us see how it can be represented. Electron dot diagram for one hydrogen atom. Now, electron dot diagram for the other hydrogen atom. Now, electron dot diagram for oxygen atom showing the overlapping. 2 plus 2 plus 1 plus 1 makes 6 electrons of oxygen. In the diagram, you can see 2 electrons of oxygen paired separately with the electron of 2 different hydrogen atoms and forms 2 single bonds, one each with 1 hydrogen atom. So, oxygen has formed one single bond with one hydrogen atom on the left hand side and another single bond with the other hydrogen atom on the right hand side. I am referring to these atoms as left hand side and right hand side only as per the diagram that is shown here. Because when we learn the shape of water molecule, the shape is different. We will come to that later. The molecule of water can be shown as is shown above. Hydrogen, single bond oxygen, single bond hydrogen, and oxygen has two lone pairs. Now, we will see carbon tetrachloride molecule. The molecular formula of carbon tetrachloride is CCl4. What does it suggest? There is one carbon atom and 4 chlorine atoms in one molecule of carbon tetrachloride. We will first represent the electron dot diagram of the 4 chlorine atoms. From the diagram, we can easily understand each chlorine atom requires one more electron to complete the octet. We have already seen that. Now, carbon. Carbon is the central atom and its atomic number is 6. Electron configuration is 2, 4. So, it has 4 electrons in its outermost shell. These 4 electrons share 1 electron with each chlorine atom. Now, you can see carbon has 8 electrons in its outermost shell. Chlorine atoms also have 8 electrons in their outermost shell. Carbon forms single bonds with each chlorine atom because one pair of electron is shared with each chlorine atom. I hope it is clear. In water molecule, oxygen forms 2 single bonds with 2 separate hydrogen atoms. Now, how do we represent carbon tetrachloride? Carbon in the center, then 4 bonds on 4 sides, each bond with 1 chlorine atom. Each of the bond is paired with 1 chlorine atom each. This is how it is represented. Now, here we have discussed only single bonds and the molecules are simple molecules. One single bond results when one pair of electron is shared. In each pair, here we have seen that one electron belongs to one atom and the other electron belongs to the other atom. In this video, we have discussed only single bonds. In the coming videos, we will discuss more types of bonds. Now, what are the points to be remembered when we draw electron dot diagram of molecules? The first and foremost thing is we have to ascertain which atom is the central atom. What is the procedure that is followed? We consider the electronegativity of the participating atoms. The atom with the least electronegativity will be the central atom and the other atoms will be placed around it. In the case of water molecule, oxygen has least electronegativity when compared with hydrogen. So, oxygen occupies the central position. When we come to carbon tetrachloride, carbon is less electronegative than chlorine. So, carbon occupies the central position and chlorine atoms occupy the outer position. That is how it is decided. Then what is the next point that you have to remember? Then you have to consider, you have to form the bonds, no? So, how do we decide? Next you have to decide the bonding. For that we consider the total number of valence electrons in each atom. After considering the valence electrons, the required number of electrons for completing the octet should be made available by showing the pairing. That is formation of the bond, sharing the electron with another atom and then place them accordingly so that they get either the duplet in the case of hydrogen or octet in the case of other atoms. So, the overlapping should be shown correctly. So, finally, all the atoms should have octet structure excepting hydrogen. In the next video, we will see how electron dot diagrams are drawn for multiple bonds, then certain ions and certain other types of molecules. I hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. Do not forget to subscribe and press the bell button and all button for notification of more videos like this. Thank you very much. Bye for the present. Take care.